Hi, this is Victor Morganti from Vive. You're looking at the Boston Conceptual Modeling tool. Today we'll be looking at a few features of Boston, but in particular we'll be looking at a very unique database that is ideal for customers using the Boston Conceptual Modeling tool. Before us we have a model of a cinema booking conceptual model or schema, where a cinema has rows and seats, and the seats are in a section. At the cinema there are sessions for films, and where the session is at a particular date and time, and where a person can make bookings for sessions. So the original model was provided by DataConstellation, and we'll put a link to their copyright in the link in the description below. This is looking at the schema from a graph database or a property graph schema perspective. If we wanted to look at the same schema from a entity relationship model diagram perspective, we can just morph to the ER diagram, and that's the same conceptual schema as a entity relationship diagram. In particular, I want to have a look at this relationship here, which is a many-to-many relationship. So a booking ultimately has one or more seats, and a seat can have one or more bookings, and where there are quite a few columns in the or attributes within the entities that are foreign keys to the booking table and also to the seat table within the booking has seat many-to-many join table or entity. Now if we go back to the property graph schema, within a graph database things are a lot easier. So we just have an edge or a relationship between booking and seat, where a booking has a seat and seat conversely has a booking. It's much easier to visualize the relationship within a property graph schema. If we have a look at the object role model for the same schema, we can see that that same many-to-many relationship is represented by a fact type. And also in particular, what I'd like to focus on here is this subset constraint here, which says that when a person makes a booking for a session and has allocated seats, if we just click on that subset constraint, what it is saying is that when we allocate that seat to a booking, that seat must be within a session at a cinema that contains a row that contains that seat. So quite obviously that seat needs to be in a cinema that is showing the session that we're booking against. So if we wanted to go and see the movie Rocky on the 18th of August 2018, we want to make sure that the seat that we book is in a row at a cinema that has a session for the film Rocky and on that date. So let's just go back again and have a look at the entity relationship diagram. So what we're saying is when we allocate a seat to a booking, we want to make sure that the seat is in a row in a cinema that has a session for the date that we're looking at, for the film that we're looking at. And once again, the property graph schema. Now I'd like to direct you to having a look at the Matisse Database, which is a very unique database, which is a object relational database, where the schema for objects or classes within the database are drawn as a UML class diagram, and where there are features which are just perfect for people working with object role modeling, even if you want to conceptualize your database as a type of graph, or even if you wanted to conceptualize it as you would an entity relationship diagram. What I'd particularly like to point you to is that each relation within a Matisse database has predicates. So a booking is for a seat, and a seat has a booking. And we have the option within Matisse to do two things. We can create the relation or the relationship directly between the classes, or if we want to, we can set up exactly the same as we would with a relational database, a many-to-many join table, or class or object class in this case. So if we have a look at this booking seat class here, that would be the same as our booking has seat entity within our entity relationship diagram. And if we go back to Matisse again and have a look at this relationship here, that would be the same as our direct relationship within a graph database. So again, we can set up relationships with predicates. The beauty of Matisse is that you can also query the database directly based on the relationships. So if we go to the Enterprise Manager of Matisse, which is the conduit to looking inside the database, over here we can see the classes in the Cinema Bookings namespace or the database for the Cinema Bookings schema, and we have bookings and cinemas and films and people and rows and seats and sections and sessions. And when we query the Matisse database, we can use Matisse Sql, which has pretty much all the features of standard SQL, but also incorporates relationships as first-class citizens within the query language. So select from seat, and we see we have 3 seats, A, B and C, within Cinema 1. Now let's do something a little bit tricky here. Let's say select seat is in row name, seat is in row is in cinema, name, actually we want a row number, not a row name, and we want the letter of the seat. So we say that there's 3 seats that we've set up, A, B and C, in row 1 in the Hoyt's Can Cinema. So what we've done there is we've gone seat is in row and returned the row number of the row, and we've said that row is in a cinema, and we've returned the name of the cinema. So going back to the Matisse SQL, seat is in row and returning the row number, seat is in row is in cinema and returning the name of the cinema, and then we're just returning the seat letter. Now it gets even better when we want to do some fairly tricky queries on the database. Now if we wanted to go and see the movie Rocky on the 18th of August 2018, and we wanted to find a seat that we could book, we need to make a query, and I'll just get rid of this lower part, and we want to return the row number of the seat, we want to return the seat letter and the cinema. From seat, and we're just saying from seat, where the seat either doesn't have a booking, or if it does have a booking, that booking isn't for Rocky on the 18th of August, which will return the seats that are available to see Rocky on the 18th. And just hitting go on that, so we see that seats B and C in row 1 in the Hoyt's Can Cinema are available. But don't forget, we want to respect also, if we go back to the object role model, that seat needs to be in a row in a cinema, sure enough, but it also has to have a session on that date for the film Rocky. So if we extend the query to say, and where the seat is in a row in a cinema that hosts a session for a film Rocky, and where the seat is in a row in a cinema that hosts a session on the date, the 18th of August 2018, and hit go, we'll get the same two rows back, and we've made doubly sure that we have the right seats that are available to go and see Rocky on the 18th of August 2018. So Matisse is quite an exceptional database from the perspective that it supports classes with relationships with predicates, and where we can use Matisse Sql to transverse the schema using the relationships and their predicates to make querying the database a lot easier. Thank you very much for watching. I hope you enjoyed this video. Please hit like and subscribe, and I'll see you in the next video.